Should we go?
Yeah.
You guys joining? This is going to be the most banging session.
That's better.
You're picking it up now.
Right. Well, hello everyone. I hope you had a great lunch. I'm Marloes.
I'm Ali.
And today we're going to talk to you about cryptocurrencies and Bitcoin and blockchain. This was something we heard at the IMA launch back in London a few months ago, was something this community wanted to hear more about. So we wanted to share with you some of the key concepts so that you can decide for yourselves whether and how this emerging technology could be useful. So first off, just a kind of hands up, because we just came in at the end of Brett's session. Who went to Brett's session? Who has heard of Bitcoin? Everyone. If this is like, I know everything, and this is nothing, what do you feel you know about Bitcoin? Okay, so there's room for improvement, but some experts as well, which is great, because we're not fully experts either. Okay.
Cool. So, we're going to do just a quick introduction to us.
Yes.
Yeah, and the lab. My background, it's not in the program, but I was one of the co-founders of a company called Decoded, which is an education technology company. We took people from zero skills and experience to building their own apps in a day. But the idea is people need to understand technology to truly appreciate and apply it in their world. I think the thrust of this workshop is, if we're going to build a new economy, if we're going to build an independent money alliance, we need to marry all these amazing ideas with this great new potential that the technology behind Bitcoin offers us. At Decoder, we believe in the principles of no one gets left behind. There's no such thing as a silly question. And we have to understand these principles. We have to understand how it works. So over the next hour, we're going to look in quite a lot of detail, but through some fun, interactive games, should we call them?
Yeah.
Games. And we're going to really understand how this stuff works. And you're going to leave feeling genuinely empowered. The empowering opportunities in fintech, it's about you guys leaving here knowing how it works and taking that knowledge and applying it to your existing projects. And,
Yeah. And there may be, for those of you who know something about Bitcoin, there may be different views in this room about how useful it is or valuable. That's fine, but I think what we both believe is that it's still really important and possible to understand it. And just to give you some kind of key stats on why it's important, there's, I think, currently 900 cryptocurrencies in the world. A Bitcoin was worth less than 1p back in 2009, and now it's worth over £4,700.
5,800.
Oh.
Is it?
I checked today, it was 4,600. So it's moving all the time. And in the latest global blockchain benchmarking study, they found that 77% of governments are experimenting with blockchain technology. So this is really important to know about for money and finance, but also other sectors. So a bit of background about me and the lab. So I work for the Finance Innovation Lab. We believe that we can build a new financial system that serves people and planet. And so we support people and ideas that have potential to make finance more responsible, democratic, and fair. And we really believe that people made the system as it is now, so we can get involved and change it again. So I work with Ali on the fellowship, and Brett is a senior fellow. He's been at the lab for ages, since it began. And we work with all sorts of people, from policymakers to people who work in mainstream banks who want to change things, to campaigners. So a few years ago, I was working at Oxfam as a campaigner. I needed to upskill myself because I didn't know about finance, and so I went on a program run by the lab to learn about that. But now, my role is to work with the entrepreneurs in finance. So if you were in Brett's session, he mentioned the tech stars in finance. There's a lot of hype about Fintech, so that's the application of technologies like blockchain, also AI, APIs, these things you may have heard of, to finance. And There's a lot of government support for it because government sees this as the future of London and the UK leading global finance. There's a lot of money going into this sector, and we're being asked or forced to use this new technology, whether it's through online banking or robo-advisors. I saw a video recently of a new robo-advisor called Ava. She's got a very husky, sexy voice, and in the video ad for her, she is speaking to a very rich man about what she could buy his father for his birthday, and then he kind of shuts her up. So it's just a really good example of how this technology can really exacerbate existing problems in our society. And at the lab, our view is that tech is not necessarily good or bad. It's all about the purpose of that technology applied to finance, the motivation behind it, and the business model. So that's really key.
And the people that use it, which has to be you guys, which is why it's so important that you guys understand this, this tech stuff. Because otherwise it's going to go off and it's going to be done by the boys in the basements and their pizza and doing all the, all that, stereotypical techie stuff. It's going to be built by them rather than us, rather than you guys.
Yeah. So let's get back to cryptocurrencies.
Cryptocurrencies. Yeah.
We're going to, in this space, create our own little economy. We want to transact with each other, and we're going to play around with some different ways of doing that, just like the coders around the world are doing that, creating new monetary systems and economic systems based on blockchain technology. So to start, we're going to create a kind of a model of the economic system as it is. So we need a banker. Who's going to be our banker?
All right, guys, you up for this? Yeah, we're going to. Can I just get? Yeah,
great.
Amazing.
Come on here. So you've got a ledger, pen and a bit of paper. So if anyone wants to trade anything, and we need to trade in our economy, it needs to go through our banker, Anna. So you all need to decide what you're going to trade. Does anybody have a particular profession or something they want to we need to get warmed up.
Yeah. So, should we all stand up?
What have you, yeah.
Arms.
Yeah?
This guy's selling,
money.
he's selling arms.
Amazing. Arms dealer.
Anyone else?
I'm selling vegetables.
Zookeeper, veggies.
Wicked.
Software.
Amazing.
Brilliant.
Any other services? Medical services and motorcycles. Amazing. Any care to offer anything in our new
Knowledge?
knowledge? Amazing.
Any good?
Knowledge. Brilliant. Go on.
Financial advice.
Financial advice. Fantastic. Any more for any more?
Money laundering facility.
Amazing.
Drugs, anyone?
Okay, I'll be in touch with you.
Drug dealer. Excellent.
Hugs.
Hugs. Oh,
Drugs and hugs. This is great. We could call the new currency drugs and hugs.
So, because we're in the current state of the world, there's some inequality. We're going to model this by saying that every man in the room has £10 and every woman in the room has no pounds. So you're going to have to sell to get some money.
Sell hugs.
So it's quite an extreme version of reality, but there's some truth to it. So what we need you to do is find a pair, make a trade, and then let the banker know that you've made the trade. Okay? And we have to just trust the banker to keep an accurate record of all our transactions. Okay, go. Say hello to someone, transact, and let the banker know.
You definitely need some vegetables off me, dear.
Do I?
Yes, you definitely need some vegetables. And I can't buy anything because I'm a woman.
Well, I am selling arms,
Yeah.
so
Well, I think you'll have to buy some vegetables.
Gotta go. Oh, banker, you've got.
Oh, hello.
So I just bought £1
Just
worth.
bought an anti-inflammatory salve for one.
Okay, so who are you?
I'm the...
Make sure you let the banker know.
This one, and you are?
I'm the
Software.
Okay, yeah. And how much was you? And I received the one. Okay, so you got right. Great, thank you very much.
But, you know, feel free if you want to
He's a money launderer.
Yeah.
He's agreed to launder £1 million worth of cash for a client, and he's going to take 30%.
Okay, brilliant.
Which is 300 grand.
So you are receiving 300 grand.
I am, and I'm putting it into Bitcoin. It's a milestone.
All in pounds. All in pounds at the minute.
Yeah, okay. I think I'm going to end up rich.
He's bought some vegetables from me, but he only paid £1.
Okay. So tight. So
I've received £1.
You've received £1.
Because I remember
and you
I'm
have
a
lost
woman.
£1. Right. Oh yeah. Okay. Sorry. Yeah. Right.
Drugs? Don't be shy.
It's an easier sale. It's an easier sale. So you've received £2. Everything's got lost £2.
Hello. I just hired Joanna for cleaning.
Okay.
Cleaning my motorcycles for £5.
This game is nobody's approached me for drugs.
The back is closed today.
It's 5 p.m. It's done now. Okay. How would that feel? Yeah. Unjust. Did you make
Unrealistic, nobody approached me for drugs.
Same here.
Do we sell any hugs?
Well, we have an equitable handshake at the end of it. I mean, that's the first step.
Okay. Let's say we wanted to propose some new economic rules to our banker. Let's say we wanted to... What policy might we want to introduce into our...
Well, I think the women should have twice as much as the men, because they spend more sensibly.
Yeah. Okay, that's the first rule. There's going to be a redistribution along gender lines. Perfect. What other rules do we want the banker to accept?
We should own the bank.
We should own the bank. Okay. So we're going to put the bank into public ownership. Wicked. What other rules do we need to...
Decentralise the bank a bit, because it's a bit of a squash all getting to Anna.
It was a bit of a squash. Okay. More tellers. More... Yeah. Any other rules? Let's be radical, guys.
Take money out of the equation.
Okay.
There's a cap on the amount any individual is allowed to accumulate in their account before it's redistributed.
Lovely.
It's everyone.
Yeah.
Could have a taxation system.
1% to charity.
1% charity, amazing. Okay, guys, now's the time. Get your ideas in. This is going to revolutionise the financial system.
Well, money does evaporate if it's lying around. I don't know how you say it.
Yeah.
So Marloes the economist, I'm the techie by the way, that's our thing. Okay, right, we've got a list of demands.
If we put this to the banker, what do you think the banker's going to say?
No.
I think we need to get rid of the banker.
Let's give the banker a chance. Alex, can we do all this stuff, please?
Well, some of those things might make me money and some of them might not make me money, so I'll do the things that make me feel good, but the other ones you can keep those.
All right, you're out of here. Get out of here. Thank you very much. Okay. Right, we're going to run this scenario again. But this time, rather than there being one banker with the ledger of transactions, we are all going to participate by maintaining a ledger of transactions.
So everybody needs a pen and a bit of paper.
It's great collaboration happening in our decentralised network already. Yeah. Sharing paper, passing pens around. Thank you. Has everyone got a pen? Mm-hmm. You haven't got a pen?
Was the paper
why don't you form a mining pool with overhead? No, we haven't. Thanks. Okay.
Okay, so we're going to take on board some of those suggestions. We're going going to become a decentralized network, and we're going to make sure that it's equal. So everybody now has 10 what we've called IMA coins, which sounds quite funny.
You're a coin.
And what we're going to ask you to do is keep your own ledger of what's being traded in the economy. And so, if you're going to make a transaction with somebody else, you need to make sure everybody else can hear it, so that everyone can keep an accurate record on the ledger. Okay?
Should we?
And the way we record that on your ledger is name, amount, name. So it would be Marloes gives £10 to Ali.
10 IMA coins.
10 IMA coins to Ali. Yeah. So
it's from and to.
From and to. Yeah, so ideally we'll all end up with a very similar looking ledger at the end of it. So, who didn't get their transactions into the bank first time round? Okay, let's start with you guys. You can shout out the person who's transacting from and to, and we'll all write it down.
Okay, well, I procured the research project services of Diana for £10. So it's Neil, £10 to Diana.
Yeah, it's Diana. It's spelled like Diana, so if that's easier.
Okay. Neil and Diana.
Okay. Neil, 10, Diana. Amazing. Who's next? Mel.
So, Ali, 30, Mel.
How many?
It was 30, wasn't it?
Didn't hear. Ali 30 to Mel.
Yes. That was for health services consultation.
I don't know that.
Who's next?
Mike.
How much?
We're going for £1.
Ken.
Mike, £1.
I've left the country with it.
£1. Can we ask what it was for? No, don't tell us.
Software to help him launder money.
Don't tell us. Hopefully it's anonymous.
It's not web, so it's not recorded anywhere.
Go on.
Andrew, to Mike, 300,000.
You didn't have to.
Hang on a minute.
You only had 10.
I thought we only had 10 IMA coins. So
you had to borrow to pay me.
But this raises a really interesting issue, because with a system like this, what's to stop people from lying about how much they're trading? Right?
Maybe we did need the bank after all.
Does the system overall know the total in the whole system to flag up that that doesn't exist?
Exactly. So how would we, from this ledger, work out how, whether enough coins are, or whether people were overspending the coins?
Well, if we've all got 10 each, multiply it by the number of people, and that's the total in the system. Well, that can't be great.
And by looking at this ledger, you can instantly see that that one's too much, that Andrew's one was too much. Andrew, which one was yours too, just to finish it off?
To Mike, he laundered some money for a client.
Okay, amazing. Let's get a couple more transactions in though, just to create. Actually, maybe we'll save them up for the next round. Has anyone got a transaction ready to go? Yeah.
Martin won Bobby for
Lost.
a veg box.
Martin, 1 to Bobby for the veg box. But we don't know it's the veg box. That's nice actually, veg box.
That's too expensive.
Okay, so we are all participants in the system. Obviously we've been saying we're taking it in turns, but computers can do things incredibly fast, and the Bitcoin protocol, you just spray your transactions out into the Bitcoin network, and all the participating nodes collect all these transactions like we're doing here, yeah? And this is what you end up with. We've all got a record of what everyone's said.
Yeah.
So, this question of, we can all see that there's been more spent. How do we fix this? Well, you tell us, guys. How would we solve this problem if we were working together as participants in the network?
You should give me 51% of the network, and then I'll sort it out.
Okay, great, guys. That sounds good to me, yeah?
Could you blacklist the one that's done it wrong and say you're not allowed to participate?
Would we blacklist? How would we blacklist?
How do you get rid of it? I don't know.
Because it's literally just a name. That name could be anything. Yeah.
Right,
and this, you could, Andrew could say, but tomorrow it could be Andrew too, and we'd be like,
So there's no identity attached to these transactions?
These in the real Bitcoin are just arbitrary strings of this number, really, it's just a number. Go on.
Yeah, well, one thing, of course, it would be that you have to put the initial account sum, because otherwise... Yeah.
So yes, we absolutely, as you said before, we need to all know the rules of the system. We need to know how many coins there are, and from the beginning, where those coins have gone. We need to be able to, through a series of these ledgers, we need to be able to trace the transaction history. Yeah? Assuming we can do that, go on. How are we going to fix this? How might we go on?
You could offer a reward to anybody who notices that there's a problem and then give them a Bitcoin every time they do it.
Yeah, that sounds like an interesting idea worth exploring. Yeah. So, the idea is, what if every now and again, every few minutes, somebody goes through all the transactions back to the beginning, the genesis of the system, and checks, okay, do these transactions look accurate? And also just tidy up the system, because once everybody's trading at the same time, it could all be a bit of a mess. And so that person run through the system, tot it all up, and then let us know what the latest state of the transactions are.
But how can you resolve the issues if you don't know the identity of the humans? We're trying to create a system here that's got no humans.
So would
I'm
you
not quite sure how that flies.
Would you devalue the bitcoins then, because actually they're worth less if people are inventing them?
So, two questions there. How can you do this without knowing who the humans are? If we know there's a fixed amount of these numbers, that everyone's got 10. In IMA coin, we all know that everyone's got 10. And we know that here someone spent 30 and here, we can immediately tell that's a fraudulent transaction, if this is the first ever thing. Later on, if we have this one, I borrowed this. Let's say this is a different group of transactions, and this is like in one round, this is the next round, yeah? You can say, okay, in this round of transactions, let's say Ken, who's got 1, let's say Ken transferred 1 to Mel. Let's say that happened over here. We could trace that transaction from Mel to Ken, and then in this one we can see that Ken has 1, and you can trace that all the way back, all the way back, all the way back to the beginning. Yeah? So you can verify that the numbers add up.
I think the question was more, in the Bitcoin system, people are not identified by their names.
Yeah.
They're identified by a pseudonym that takes the form of a number.
So each individual still has a unique identifier.
Unique identity, but it's not
okay,
identical.
so that's fine.
We're trying to make it identical.
Perfect. Thank you. Yeah? Cool. And then what was the second question?
I just wondered if there are fraudulent transactions, whether you devalued the Bitcoin, because everybody's is devalued if someone's got stuff they haven't got.
Then the value of that currency is going to go down.
If Andrew could just make up 300,000 Bitcoin and send them to Mike, then we're in trouble. You know, we can't work with that. So we have.
Because everybody sees it. They all go, hey, that's not allowed.
Yeah, exactly. So what we want is every time period, every few minutes, we want to nominate one of you guys who's doing the ledger to check those, check the maths, calculate that there aren't any overspending, or people aren't spending the same money twice. Yeah? And then say, guys, this is the ledger. And we all somehow, and this is the next question that we're going to explore in more detail, we all somehow have to trust that person. Be like, okay, yeah, Mel's copy of the ledger. Mel's the
checker.
Totter. What are we going to call it?
The totter-upper.
Totter-upper. Yeah.
Tally woman.
Yeah, but with non-gender,
Yeah.
Totter-upper. And we're like, yeah, we trust Mel. So we're all going to like dismiss our ledgers, and we're going to take Mel's one, and then we're going to carry on from there. Yeah. So, does that make sense? Are there questions? Should we do a quick round of questions?
Yeah, I just wanted to check. So I find 2 suspects, all incorrect items in there. What do I do as totter-upper? Can I just cancel them?
As totter-upper, you literally put a line through them. You actually start writing out again on a new sheet with just the clean ones, and then that's the sheet. They become null and void. We reject that. And so your 300,000 laundered money hasn't done that, sorry, but...
No, you do, yeah. Rookie error.
Yeah. But it's fine, but because you haven't provided the services yet, because you wait for the confirmation, you know. So it's totally chill.
Does that mean that the transactions are not valid till the totter-upper have said, okay, carry on?
Absolutely right. Yeah? This is a big concept. Should we more questions about it? Are you guys happy? Great, yeah? Okay, good.
Should we go through some of the history now?
Yes.
A little break from the exercise.
Yeah. Great shout, Marloes. It's wicked. Who's this? Does anyone recognise this guy?
He had some drugs for Ethereum.
Some drugs for Ethereum.
Okay, this is Nick Szabo, and he is a computer scientist, legal professional. We're going to come to that in a minute. He is, well, we'll come to it. Basically, we believe at the Finance Innovation Lab. No, yeah, no. But to understand like the whys and the hows of technology, we basically want to understand how Bitcoin solved this problem of who's the totter-upper. Yeah, this consensus thing. How do we all agree? And this guy, Nick Szabo, came up with a pretty good answer in the form of this thing called BitGold, which is a precursor to Bitcoin. I think it's interesting to explore his motivations a little bit. So what would be the first thing you'd say about him, Marloes?
Well, we understand that he's a libertarian, so he has a particular political ideology. And if you remember at the beginning, I said that it's really important to understand people's motivations and when they're applying technology to finance. And so I think understanding his political ideology is important to understanding all sorts of things about him and what he's trying to do.
Absolutely.
So and this is a quote from him, and he said that a key issue with the current way of doing things is this point about having to rely on a trusted third party like the banker, which is something perhaps many of us could agree with is problematic, because in the current system in the UK, banks have a huge amount of power.
Yeah. So he was also a visionary. He said this. He said that hardly anybody actually understands money. Money just doesn't work like that. People always told him. So he's got this like radical idea of what money can be. You know, it doesn't need to be gold. It doesn't need to be that it could just be these completely secure digital bits on a network that are secure that you know can't be faked because of what we were talking about just before. And you know, he recognises that idea that Yuval Noah Harari puts out in that book *Sapiens*. Have you read this book *Sapiens*? It's all just shared fiction. You know, what we choose to believe is what we believe. You know, the church, Persia, all these things. Maybe money as well. So he had an alternative view of what money could be.
And that again might be something we can all share in this room.
And then lastly, he was a legal expert and a cryptographer. He's like a proper academic, did all this like mad stuff. He's part of this interesting movement about cryptography as a way of protecting yourself from prying eyes of the state, all that sort of stuff. And part of this is we want to help empower you guys with that ability to critically evaluate this stuff as well. You know, like do we, so it's this coming together. He was literally uniquely placed to come up with Bitcoin, but he actually didn't, did he?
No, so 3 years after his BitGold project was launched, Satoshi Nakamoto, which we don't know who that person is or group is, published a paper that was the beginning of Bitcoin, and that was in 2009.
And it contained a lot of Nick Szabo's ideas. So it was putting together a peer-to-peer system. Who's used BitTorrent back in the day? Yeah. And it was a combination of peer-to-peer, cryptography, and these new ideas. But he hadn't solved. Nick Szabo hadn't solved the issue of how do you choose the totter-upper. You know, that hadn't been solved yet. And then Satoshi Nakamoto came along with this beautiful solution and a working implementation of it in code. You could install on your server, everyone could install it, and suddenly you've got a network where you can have this distributed network where people can trade, and we've done it. So how did they do that, Marloes?
Well, let's try it out.
Yeah.
So we're going to fire up IMA Coin 2.0.
Are you excited? Yeah? Is it all making sense so far?
Yeah.
Yeah? Cool.
Any questions?
If you're thinking it, someone else is thinking it. Yeah. People heard of Satoshi Nakamoto?
Yeah.
Do we think it was that Australian bloke?
Yeah.
Probably not. I don't know. Okay, wicked. IMA 2.0.
Yeah.
What are we going to do?
So there are actually a number of ways to try and start to wrap up. We want to run through two. Proof of work is the one that is used in Bitcoin and a number of other cryptocurrencies. And it can help us solve this issue of how do we trust the totterupper. And the way that they do it in Bitcoin is they make you work really hard. And so we've got a little
game.
To show you. It's kind of an analogy to how it works. Really.
So, go. Oh, prizes. This wins prizes. The way that Bitcoin protocol works is that whoever gets this number right is going to win 12 new IMA coins. In our system, what should we do in IMA coin? How should we create our coin
free hug?
issuance? Yeah, free. There should be some incentive because we're asking you to do quite a difficult maths puzzle. Guys, I'd be getting your calculators out, are you? No one's getting their calculator out. You guys are very confident. It is hard, but it's not that hard. So what number can you multiply this by to create? Okay, we'll give you a clue. It's a single digit number. No? No, I wouldn't say that. No,
really, try and have a go.
8.
They got there first.
It's not 8.
4.
It's not 8, guys.
Yeah, it's 4, isn't it?
Is it 4? What number is it?
6.
6? I can get my calculator out. Are we checking it? What number is it? What is it?
I thought it was 8. Yeah.
So let's all check.
6-digit number.
28,375 times 8, 227,000. So we're all saying it is 8, yeah?
It's 8.
Wicked. Who got it first?
Somewhere.
Who was it? We know.
It was just
It's
shown.
the most beautiful thing, isn't it?
Who are we saying it was?
We share both.
That doesn't work. You can't have two people win, that's the whole point, right?
We get it at the same time.
Well, the mining pools, and they will, everyone will contribute their computing power, and then they'll just share it out. Is that right? Yeah, that's right. So, what happened there? We posed a problem. You guys solved it. One person solved it first. We all checked it afterwards because we weren't sure. Yeah, and we can all agree quite easily by multiplying 28,000 times over by 8. We can see that that's the result. So the checking of it is quite easy, but the doing of it, if I hadn't said it's a single-digit number, you would have been like, what? Or how would you have done that? How would you have solved it? Go on.
First, the 75 needs to sum up to an even number.
Yeah.
So it could be 5, 4, or 8.
Yeah.
4 wasn't, because if you then multiply 300 by 4, you don't get 1,000 but 1,100, so it must be 8.
Very good maths. Well done. I was thinking that you have to start at 1 and just work through it.
Well, that's the other way.
Yes. But that's how. So the one in Bitcoin and the one in most blockchain-based proof of stakes is you're taking all the transactions and you're basically running them through this special function that turns them into a number, and you're doing it again and again and again and again and again until you get one with a certain number of zeros in it. It really is that arbitrary.
And you can't use logic in the way that you just did. You just have to do trial and error and just run that equation again and again and again.
Yeah.
So it's quite a random maths problem. And with the way it works in Bitcoin, it uses a hell of a lot of energy, actually. So loads of computers are trying to solve this problem all around the world. Yeah.
Huge. What is it? We did some research in preparation for this. Go on, Brett.
Maybe like style of thing in computing. This concept, you find it, for example, in anti-spam systems. So, for example, if it's like super simple to send out emails, you could find a spammer who's just like, I can send out 100,000 emails, it's not going to really matter to me. I can send as many spam emails as I want. Let's hypothetically say you wanted to slow them down or like make it hard for them to do it. You could say something like, before you're allowed to send an email, you have to solve an arbitrary maths problem, which is quite hard, like a particularly difficult one to solve. All right, if you're a person who's got a single email you're trying to solve, maybe it'll only take you, a single email you want to send, maybe it'll take you like 30 seconds, right, and it's fine. But imagine you're trying to send 100,000 now. That will like completely slow your ability down. So like these types of systems that we're developing have all these other uses on the internet where you like deliberately make it harder for somebody to use a digital system to try and put like friction and work into the system. This is because it makes your computer have to do all this stuff, right? So this is like part of the backstory for this, these styles of proof of work systems.
That's really nice because it goes against, you know, we're always trying to make computers go faster. You know, just last night, the project I'm doing, we were trying to make the database run faster because it, you know, always trying to make it. But actually, if we can go slow and get this outcome whereby we're actually stopping spammers, or we're verifying, we're making it possible to say, Mel's a tosser. You know, you've put that work in, you've done all those numbers, you've like typed into your calculator a million times a random number, and then you've got it. You know, we can trust you. You've put the work in. You know, the chances, if you're prepared to go to that length and burn all that electricity, we can trust you. You know, and this is, I mean, is it worth starting the discussion around it, or
energy?
The energy stuff, yeah.
Well, we're just looking at some stats on the train here. This process does use a lot of energy, as I was saying, and it's equivalent to the electricity use of 1.25 million US households currently, but it will be going up. It's also the equivalent power use.
I get it all right.
All right.
That's not part of the game.
Sorry It's also, Bitcoin also uses power equivalent to the power usage of Iceland.
Is that power usage just in the mine? Or is it also a lot of power required in the maintaining of the ledgers of the chain?
Great question. The answer is that they're the same thing. We don't want to go into too much detail here. We want to give you the high-level stuff, but the mining is the maintenance of the ledger. By solving this mathematical puzzle, you are actually verifying the transactions.
If you had a copy of the ledger on your PC, you're not required to have lots of...
You don't have to turn mining on. If you install Bitcoin software, you can send out transactions. If you enable mining, then suddenly your hardware will start doing these.
You can't join the maintenance of the blockchain unless you're a miner.
Yeah, exactly right.
Yeah, so no, I appreciate you want to stay at a high level, but I just want to make sure I don't lose a link in between. Sure. This Totoropa, so they have to do this mining proof of work in order to earn the right to be the Totoropa. And how often do you change the Totoropa?
So, every 10 minutes on the Bitcoin network, it's however much computing power, however many people there are who want to have a crack at getting those 12 Bitcoins, they will all contribute their computing power. The Bitcoin protocol, the underlying code that's running on all the servers, is aware of it's almost like a self-aware thing, it's amazing. It's aware of the total amount of, it's called hashing power on the network, which is the computing power that's available. And it says, okay, we want it to take 10 minutes. We want there to be 10 minutes in between each new Totoropa coming up and verifying and creating the new version of the ledger that everyone can agree on. 10 minutes, okay, so if the hashing power on the network is currently 52 gigahashes, which is 52 billion hashes a second, like these functions of like, one guess a second, then based on, we want to get a number with, we said 3 zeros, they're like 17 leading zeros out of a 32 character number. We calculate basic probability that we should set a difficulty setting, which is this arbitrary thing they set, an arbitrary thing they set, to this. And then when the miners all subscribe to that, they will look at the difficulty setting, they will look at the problem, and they will solve it. And it means that you will always, no matter how much power, no matter how many people, it will always take 10 minutes. Does that make sense?
Yeah, it does.
Great.
Is it useful to be to add in stuff while you guys are going?
Yeah.
Because I think it might be helpful to understand that in the original example, we had a banker who is paid to maintain these ledgers. They get a salary to do it, and they will maintain it. This will be an old team or whatever, right? But like they're paid to do it. If you want to try and get a decentralized network of people to do that same job, you have to like set up this like circuit type mechanism, which is to say, we want to incentivize you to do it. We will issue you new tokens if you are able to do it. And the person says, okay, if I'm able to do it, I'll get these new tokens, but like, why will these tokens be worth anything? If it's like really easy to do it, like thousands of people just get these tokens, it'll just be like massive, like I'll be getting meaningless tokens, right? So like the system has to create this like dynamic tension. It has to say, we'll make it hard to do the job of updating the ledger, all right? So it won't be easy to do, and this will kind of be part of the psychological, the sort of dynamic that makes it worth getting the tokens in the end. So like you have these sort of different parts you kind of hold in your mind.
And it's based,
which is what's part of the proof of work thing. So it'll always be like, the difficulty will always be made to essentially make it like so no matter how many people are trying, you're always going to be issuing a similar number in time.
I think for me, the conceptual leap I made when looking at it was that, basically, that's why it's called mining. It's like you need to introduce scarcity. That's why gold used to back money. It's going back to the gold standard. So it's quite progressive in that sense.
And that's
it's not a liberation of money, it's actually tying it really tight back down.
Exactly. And that's Nick Szabo's views. You know, he believes that in order for something to have value, someone needs to have expended some energy. Even if the expansion of that energy is on just guessing this random number, you know? And this ties us up to this question, this debate of, do we feel as though these computers expending all this energy? Because I think the next stat was that it was, you know, Visa payment processor in the traditional sense of the word. The Bitcoin network, Iceland, yes, 1.4 million American homes, yes, it's 27 times as much energy as Visa. That's not okay, in my view. It's not okay, you know? But it's securing a network, which means that we don't need Visa. So maybe, you know, maybe it is okay, you know?
But there are alternatives.
There are alternatives.
Well. So should we introduce proof of stake?
Yeah. We have to crack on, don't we, yet?
Yeah.
Yeah? What time is it?
Yeah.
Okay. So proof of stake. So does that make sense, yeah?
Yeah.
Cool. Okay, great.
So proof of stake is another way to find our TechUK. Again, we're going to give you a reward for taking part and sorting out all the maths. But to believe you, we want you to give up temporarily some of your money. So we want you to get out your wallets, put them in there.
This is if you want to be like in with it, yeah? You want to participate.
Do you want to have a chance to win it? You might be able to use that.
And ideally we'll have alternative currencies, yeah?
Please remember what you give us. Oh, we've got some Bristol pounds here, Scottish. We've got US dollars. All the speakers are waiting for banana. Oh, what are they?
I will give
Bristol pounds.
one real pound.
£1.
Can I pay in digital?
Oh, 1p wallet. US dollars. Yeah. 1p. Yeah. 50 cents. Excellent.
You're accepting digital
Oh,
payment?
we've got some IMA coin.
Wallet.
Excellent.
Wallet.
Thank you. Please remember what you give us. Amazing.
Okay, great. So you guys are now invested in this network, yeah? How do you feel?
Wealthy.
Nervous. Good.
Yes. Really nervous.
what we're going to do now is...
Run out the job.
I think this might be the most.
Yeah? Who's the most?
I've got 100.
Did you?
100?
It's in the wallet.
Okay, you're going to be our Totterupper.
They're probably his money, yeah.
Wicked.
It's our banker again.
Hang on a second.
She didn't get that signed off by the finance director, I
Yeah, how come you've got 100%? Anyway.
Okay. So we're going to simulate now a round of transactions. How do you want to do it? Yeah. We were going to like skip over the transactions and just do the telling.
Okay.
Yeah. So Anna, if it's your turn. Basically, everyone who's got money in this pot now is staked in the network. If you produce a block of transactions which includes anything fake, we can all check it afterwards, and you're gonna lose that.
And that's ours. Oh right, okay.
Yeah. So we would like you please to produce the next block.
Oh, so I have to trade?
Should we do more trades? What's this more trades?
Yeah.
Yeah. Okay. Great. Right.
So you need to.
No. I don't understand what I'm moving us to do.
Let's do another round of trades, and then we'll mine it.
How's Anna
You're going to tell us
track?
about this.
Don't know.
Oh, I just have to tell you what's on the ledger?
Yeah.
Oh, sorry.
We have to match.
Oh, yeah, okay.
You're our Totterupper.
Yeah, tell you what.
If
you just like broadcast the ledger to us, if you just read out the transactions that you would like to go into our block. Yeah.
Yeah.
All right.
Maybe we should start with the same again, and then you need a fraudulent transaction.
Yeah. Well, no, I think we've got it.
We already got it on there, yeah.
No, great thinking. Yeah.
Oh, but I'm reading the right. I'm giving you the right ledger, right?
Well, it's up to you.
Okay. No, because I want my money back. I'm not going to read you any fraudulent ones. Neil paid 10 to Diana. Mike paid 1 to Ken. Martin paid 1 to Bobby.
How do we feel about that network? Happy?
Yeah, thanks.
Okay. Part of what we haven't maybe mentioned is that within each one of these transactions there can be a tiny transaction fee, and you just run the transaction fee.
Yeah, that's cool. And since it was accepted, you get your money back.
Or you can leave it in there, and it can grow as the value of the network increases.
Oh, so what? So that gets interest?
Essentially, yeah.
If the value of the currency appreciates.
So if no one takes it out, when they win, it goes up, the transaction fee. So when you do decide to take yours out, it's worth more.
Well, because, sorry, the transaction fees stay in the pot, or I get them?
I think it's up to you. I think you can withdraw it at any time.
You can take it or you can leave it in and let it grow, and then take it out.
And if it's still in there, then next time you'll have a chance to be the Totterupper again as well.
Okay, I'll leave it in.
These wallets and Bristol pounds and phones and things all represent IMA coins, right?
Yes, exactly.
Just to be really clear. Not just
The
any
coins
IMA
are
And
IMA.
the gamble that she's taking is that we're all still in the room, and if half of us walked out because another session was more interesting in another room, then the value of the coins that you've created would plummet because there's not enough economic activity.
That's a great point. Yeah, if you're staking the network, it's in your interest to promote the network to do it. Yeah, yeah.
What's in it for the rest of us, or how do the rest of the people that put stuff in get involved?
So great question. So we take it in turns. We make up the rules now, but probably every 10 minutes, if you want to keep it like Bitcoin, we can make it quicker to alleviate some of the concerns and criticisms of Bitcoin about transaction speeds. We can choose, a rotation. We'll be like, everyone who's got money in the pot, we'll go, right, it's your turn now, your turn now, and we can automate that based on when you put the money in the pot, you will send your address with it, and we'll know that the address that you send with it is the computer that's going to broadcast the next block. Yeah?
Why should we trust you to keep our money?
Perfect question. Thank you. So this isn't us. What this pot actually is it's called a smart contract. So it's a thing that lives on the network. It's a computer program that exists on the network in a decentralized way. And what we're going to try and talk about next was that in a bit more detail.
Yeah. One question then, I just want to raise one issue about proof of stake as well.
So if Anna got that wrong, then she would lose her £100. Why is that fair? Why?
Good question. So you can't get it wrong. The only way you get it wrong is if you were malicious. Like verifying the numbers and tracing it back to the Genesis block, that idea of, and totting up all the transactions. And as a supercomputer, you're a supercomputer. You're a supercomputer. You know, you can do this stuff in like seconds, like verify the transactions backwards. You know, we don't put any, you know, those restrictions, any like, requirements for you to guess numbers. You know, you can just run all the transactions back to the Genesis block and prove which ones are valid and which ones aren't. So the only incentive for Anna to cheat would be if she thought that she could beat everyone else in the network and put in fraudulent transactions that were more than her stake.
Cheat, but she just got it wrong.
If she got it wrong, then it's a problem with your software.
Yeah.
We turn you off and on again, I think.
Okay.
Yeah.
And yes.
It's worth conceptually separating out the idea of being able to check if a transaction is valid and everybody knowing that. So in a crypto system, I can actually check anything that gets sent to me because it's all publicly broadcast. Everything's in public. I can actually go and see like the coin that I've received that's been attributed to my name. I can like trace to see exactly where it's gone, right? And that's like all the sort of like public-private, well, there's a whole body of cryptography which is about like how you can check that. And you don't need miners to actually do that. You don't need these like official record updater people to do it, right? In theory. But if you want to create a big shared vision of what everybody's doing in the system, that's when it's like you're creating this public ledger of all the private transactions that have gone on. And then people can go back and check your individual parts of that. So a lot of this sort of stuff around proof of work, proof of stake, like it's not necessarily so much as of like the person's, like people are checking the transactions, but it's about who gets to update the ledger, the official main ledger, like the official history.
The shared single source of the truth.
Yeah, exactly. So like and then you can have these different means to decide who gets to update it. Especially if you have this like loop, which is like, if you are the person who updates it, you get rewarded with the new coins, and that's how we issue it. So like that's the kind of yeah.
Mel, you had a question?
I know, it's good. I think it was answered.
Well, I think to understand, you know, you ask why, what if I make an error and then I lose all my money? You can check yourself. You wouldn't make it publish if it's wrong, if you don't want to make it wrong. And if you miss a transaction that has been broadcast, for example, and you don't put it in your ledger, I assume now, that will just be not valid. It will be ignored and the transaction like never happened. It's not an error in that sense that you did something faulty. It's just like the transaction didn't succeed, so you will do it probably again to make it succeed in the next round. So it's not that you can really make an error without knowing it.
Okay, well, no, go on, hang on. I think we need to pick it back up from the front. Go on, Marloes, what were you going to say?
Well, I was going to say that there's different ways of doing these proofs. Proof of work, proof of stake are two popular ones. We were just talking to someone from Scottcoin who is using proof of embellished time.
Proof of elapsed time?
Elapsed time. Yeah. So there's different ways, and there's different pros and cons. One that I'm really interested in is around inequality with proof of stake. So my understanding is that you're going to get more reward for helping to update the ledger the more money you stake. But we know that that's a big problem because that just leads to
Thomas Piketty.
Yeah, inequality. So I think this is not like a finished job at all, and this is all evolving, and there's lots of things to consider, whether it's burning energy or inequality.
I will add to that, there is, of these two, of the proof of work and proof of stake, proof of stake, I think is better. I think it is an evolution on it. And there is this thing called distributed proof of stake, which is less simple than what we've done here. This is proof of stake, what we've just done here. But there's one called distributed proof of stake, which involves people clubbing together and voting, and people advocating, and there's all sorts of nuance in it, and it would take longer than an hour just to talk through distributed proof of stake, so we haven't gone into it. But it's been, it runs on this network called the Steam blockchain. Have you ever heard of Steam? It's like a social network where you can earn coin for posting, and it's really cool. And it's been on work there. So there are these alternatives. And then the Scottcoin thing, we're going to crack on. But if you're working in public, if we can't necessarily trust everyone here, which we can't, then you have to do one of proof of work or proof of stake. But if you're working in a world where actually, this is what I was doing at Everledger, you're working with all the people in the diamond industry, they all actually, they may not like each other, they all trust each other. You can install in their offices a computer connected via a blockchain network. You don't need to have a proof of work or proof of stake. You can have another proof of lapse type thing to do it. So, how are we feeling? Good? Yeah? Is it making sense? Yeah? Kind of.
Can I ask one question? I just don't see the point, because this is like a place to keep money. How do people use it then? How do they use it to transact? This seems like it's growing wealth. But how is this usable currency?
So this will only represent some of their wealth or income. But again, I think that relates to the inequality point, is that if I've got £1 million, I can easily stake some money because I've got loads of spare cash. But if I've only got £10, I'm not going to stake my money because I just need to spend it to get some food.
Yeah.
Yeah.
So for that person, it's not.
It's not great.
It's not for you.
Isn't there an incentive not to spend it?
Yeah.
You just
It seems
literally
like
hang on to it.
It's an incubator, right?
Because it might go up a bit.
Yeah, it could be.
Go on, yeah.
Well, I think what I have to say is along the lines of what you've been saying as well. Is just I'm really grateful for today because I haven't really up until now managed to get even a tiny handle on it. I feel like I understand it better. But I also just don't understand why cryptocurrencies I've heard of, the more famous ones, have to behave like tradable assets, as in fluctuate so much. And that I'm not against people making a shed load of money. I think it's exciting, but again, there's an inequality issue there. People with less knowledge, less sort of experience with it, I'm bound to be left behind. So I'd love some kind of expert. I understand how we got there, but
it's more like an investment than it is a usable
and do some
thing.
of the 900 cryptocurrencies not do that?
Can we just, I think it's worth quickly, because I think there's a lot of confusion around that, it's worth breaking apart that there's how you mine something, how you bring it into existence, the creation point is different to the ledger of transactions. So you can have a kind of a blockchain ledger of transactions which doesn't have this. You need to have capacity in the first place to generate these calls on wealth. Remember, they're not wealth itself, they're all just contracts, calls on future wealth. That's what these things, all these coins are. But the following of the transactions is different to the creation point of the contracts which call on wealth in the first place. And there's two different processes, and you can use one without the other, potentially.
Yeah, I think I know what you mean.
That's what I was wondering if it's already been done. Yeah.
Okay. So this is just the system.
Well, you can't in the Bitcoin system.
Not in the Bitcoin. But in theory, you can use a blockchain.
The blockchain protocol and the Bitcoin is not the same. It's totally different thing. The blockchain as a technology has been around for all the components of the blockchain technology has been around for what? 70s, 20, 30 years, asymmetrical and all of those stuff. Like what Brett said, in order to make people, a massive group of people that are not getting paid to do some labor work, you need to incentivize them. The incentivize is Bitcoin. It's two different things. The technology itself, the way it works, the way it processes the data, it validates the data, make it a consensus between all the participants is one thing. The Bitcoin is just the incentive. With a specific protocol, which is different from the Ethereum protocol.
Yeah, can we come on to that now? Can we see, go on, quick one, please. We're going to 10 minutes.
Most of us here, not necessarily in this room, but today are here to talk about currency, inverted commas, as a medium of exchange based in trust within a system. Can someone please distinguish for me that something which is inherently volatile up the way and down the way fits that pattern, because I don't suggest it does.
Please,
blockchain, very important. Cryptocurrency fitted in today, medium of exchange, it worries me.
Yeah, I agree. Thank you for that. Because, and I think in the last 10 minutes we can address some of these questions and concerns. Yeah?
Yeah.
We'll do it in 5 minutes, and we'll have more time for questions, yeah? So, after Bitcoin, there was this boom in cryptocurrencies, yeah? People were taking the code base of Bitcoin, creating their own new ones, all this stuff. But they all had this proof of work stuff. What then happened was, who's heard of Ethereum? It was just mentioned just there, yeah? Should we rattle through this?
Yeah.
Okay, so who's this top guy? Vitalik Buterin, yeah? So, if the Bitcoin ledger is a record of transactions, yeah? The Ethereum ledger, Ethereum is exactly the same as Bitcoin. It's a decentralized network of computers. But instead of keeping a record of transactions, what it keeps a record of is the state of a world computer. Yeah? Let's explain that in more detail. So, it contains the actual state of all of these decentralized applications. So rather than, I said this is a smart contract, it's a decentralized application. Go on, Marloes.
What is that?
What is
that?
that? So, if, who's this lady here? No? Bottom right. So that is, she's a daughter, well, she's Ada Lovelace. She was the first person to write an algorithm, which was a sequence of rules that determines how a system should behave. She did it 100 years before, who's that guy? Turing, yeah? Wicked. What did he invent? Enigma, yes. During the war, what did he come on to do? What was his thinking about? What did he actually create and invent after that? The computer. And what was the name for a computer?
Turing machine.
Turing machine, exactly. Otherwise known as a finite state machine. Okay, so if a machine can keep track of all these different variables, it can essentially simulate anything. It can compute anything. We'll leave that there. But basically, a computer is able to keep track of the state of an application. When you log on to your Facebook, actually not here, when you log on to your, whatever, everything's there, yeah? All the stuff's there, and that's because a computer is keeping track of the state of your application. Vitalik Buterin's insight was that the ledger of Bitcoin needn't just be, and this is going to come back to currencies, not just computers, needn't just be transactions. Even though the hardware and the network in Bitcoin is totally optimized for us, as we've seen, being able to make transactions and do money online without having to trust Visa or the banker. His insight was that you could design, you could write algorithms, you could have programs, contracts, applications, decentralized applications running on this distributed global network. That is a big idea, yeah? Because you've suddenly, before, you have to have a Google or an Apple to run the infrastructure to process all the privacy and security. But now, on Ethereum, we can, go on, Marloes, we can write our own rules. We can build our own coins. And this is what people have been doing. There is Ether, and Ether on Ethereum is the equivalent of Bitcoin. It's the cryptocurrency that powers the network. If you want to run a specific application, if you want to use a voting smart contract, or if you want to use a house title smart contract to transfer your housing deeds from you to someone else, if you want to
get married on Ethereum.
If you want to use the Mac, you have to send some Ether, and the miners will run your code for you, updating the state of the world computer with the different variables, with the different. You still with me? Yeah. Go on, Brett.
One of the good analogies for it, if you want to go back to this earlier stuff about you maintaining a database.
Yeah.
Like if you're doing this digitally, this would be an Excel spreadsheet.
Lovely.
All right. Like it would just be like cells in an Excel spreadsheet, and you're changing the numbers between people. Like if anybody's used Excel before, at least you're aware of it. Probably. There's these things on Excel called macros, where you can start to like automate processes. So you say like this thing will just automatically do something if I do something else. Like I don't know, it'll automatically turn this color, this thing red if it goes above this value here. So you can program all this stuff into that, and that would kind of be like what the Ethereum system is trying to do on this big decentralized scale. So you can add these enhanced functionalities into your otherwise quite sort of crude databases and make it do more fancy things.
Another example could be someone at the beginning said, in our ideal economy, what we'd ask of the banker is that if anyone's wallet reached a certain limit, we would cap it at that value. You could do that with a smart contract on Ethereum.
Okay, so we can design entirely new systems. The trouble with Ethereum, the main thing is that it exists. It's amazing. You know, I am going to have a couple of digs at it. The trouble is it's very liable to price volatility. There are a lot of people speculating on Ethereum, a lot of random people just buying the coin and then holding it. And it means that to to run any smart contract, you're paying like in pounds in your head, like loads of ether. You know, it's like, well, I'd rather not spend 25 quid on running this smart contract. You know, it doesn't feel like it's worth that much to me. Does that make sense? So it also uses proof of work underneath. Is that your question? No. Sorry.
No, actually, I just didn't want to hold you up because I know your time's short.
Yeah, go on.
Yeah. Well, no, I was just saying, would transaction tax work, or is it not a problem of big players coming in and doing lots and lots of transactions every millisecond? Like in the stock market, that's a problem.
Yeah.
Or not just the stock market, but in the
So there has been a problem on Ethereum with transactions, and it kind of grinding to a halt. Actually, a few days ago, they released a new release where everyone, all the miners, everyone who was participating, updated their software, their Ethereum software, and the transaction speeds have like quadrupled. You know, and so they're always improving it. So Ethereum uses proof of work, so there's still this mining going on. They're moving to a proof of stake, and what that means is they're going to have a smart contract running on their thing where people can deposit money and mine the transactions. But if we think of what if it's all here, like we've been thinking before, this smart contract is one of a million other smart contracts. You know, it's choice, investor choice, you could say. I'm going to put my money in the proof of stake one and let it grow with a regular network. I'm going to go and invest in a new decentralized solar-powered coin that helps people, and maybe I'll get a better return, that whole thing. Does that make sense? Ish. Very quickly, just to wrap this section up about world computers, there is a new one it's in development at the moment, that's got proof of stake built in. It's called EOS. People heard of EOS? So it's being developed by someone called Dan Larimer, who's the person behind Steam, that network thing I mentioned earlier. And it looks at all of these issues and basically tries to solve all of them. So on EOS in the future, you will be able to design a financial system which is immune from speculation. The actual token isn't affected by speculation. It uses proof of stake, it's basically all this good stuff. So what this means for us is that it's day zero in this world, and we can, if we want to, build these stable currencies which are great means of exchange, which have encoded into them these beautiful rules.
And there are examples of that. So I think Coin is one of them. I think Corda is one of them. I think that's fantastic that we're all working together, working with the latest technology, and just to reiterate what we said at the beginning, we're not saying that this is necessarily the best route, but it's so important and possible to understand what's being developed. And yeah, I hope that this has helped a little bit.
Great. Questions?
Could I have a clarification to the world computer concept? Because when I first heard that concept, I found it super weird. And actually, it's pretty straightforward. This is a single computer, right? It does inputs, outputs of data and stuff, right? It's a single insular system. But if I took a cord and connected it to that computer there, you would actually have a meta computer. You would have two computers joined together. And actually I could input stuff here that would be processed on that and then output it back here. So you actually link them up into a bigger computer. And if you take 1,000 of them in a big data center, that becomes a single big computing unit. All right, so this concept of a virtual machine or a world computer is actually just taking a ton, tens of thousands of computers, you're linking them together and you're saying, okay, you're all going to operate as one big computing unit. All right, you're going to use communication protocols. So that's kind of the internet's kind of a...
Sounds like cloud.
It's, our concept of a cloud is a centralized version of that, whereas this will be these are decentralized versions of that concept, I'd say.
Yeah. And Ethereum is different because it is built on the same cryptographically secure technology as Bitcoin. So in a decentralized way, without having to have these trust parties, these Apples or Googles or Visas that we are forced to trust because they've got it all in their data center, we can run a computer where we, in our own, wherever we want, want to have them run on computers. Does that make sense?
And just to say, we've just spent an hour on this. There's going to be so much more. We're going to be here today and tomorrow, and also you guys, we know, have lots of interesting knowledge and expertise and questions. So we will definitely keep this going tonight at the pub or tomorrow in the open space as well.
How are people feeling? It's the first time we've ever run this session. We love your feedback.
Yeah.
If we went too far, if we, yeah, go on.
I've got more questions about how this actually impacts on local currencies than I started with. But maybe that's a good thing. You know, like I want to discuss it more, and yeah, if you were to run it again, I'd keep another 15 minutes at the end to talk about it.
Yeah, agreed.
But brilliant.
Can I ask if the gentleman with the camera has kept a close eye on my wallet?
The gentleman with the camera.
Serious question. When I was talking about the comparison between the investment element and the medium of exchange element, you went on to say that you can have a stable currency. I'm not sure I was looking for a stable currency because I'm not sure the currency at that level between, I'd say a low level, right, rather than international economy, that it can stay stable. I think there will be factors like less food, right? So the farmer asks for more money. Now, I'm not saying that changes the characteristics of the thing, but there's factors going on within an economy. And that's why I keep worrying about it when it's talked about as Bank of England ran the competition, you'll know about it. There was 4 Edinburgh students who used blockchain to try and handle the makeup of blood transfusions within the NHS. Right? That was blockchain. And that to me, times everything you were talking about, begins to make some kind of rational sense to me, that you can organise a lot of human activity, which is hard to organise other than you have some kind of ongoing ledger which you can verify, like blood transfusions. That when it's transferred, it started obviously with the currency, when it's transferred to the currency side, personal view, it just worries me. I think it's perhaps removing the banker too soon.
I thought it was cool, because I've tried to run these blockchain things, and there's a bunch of I've seen loads of people trying to describe blockchain. I think this is a pretty good version. The key conceptual problem though with it is when we try to use physical analogies. So for example, you use that physical hat with notes and stuff in it. That I think throws me off, because essentially a blockchain system is it's data recording, right? So the concept of we start off with a central person who records the transactions. Then we move into this concept, okay, we're all going to collectively record the transactions, and we're going to therefore need some way to come to consensus and some kind of incentive mechanism to do it. Those concepts come through, but then it's when we start to then use physical objects and stuff, people get really confused. I tend to find I've seen people trying to use examples of skyscrapers and different rooms you go to the skyscraper to try to describe a blockchain. And my sense is we should always go back to something like Excel spreadsheets or things like that, because there is something fundamentally one of the main issues with blockchain technology right now is that essentially it's an information recording technology that you use to try and coordinate action between strangers. And one of the things is, how do you actually then connect that to the physical world? And actually people in the blockchain community don't yet know how to do that. There is no real way to fine, we can create a digital system that does something, but how is that going to then fuse into real action in the world? And you either need to do that, you have to have a legal system that says, if something is recorded in that system, then we will act in the real world, or else you somehow have to make things in the real world unusable unless you use that system. So there's a whole thing about how you fuse the digital coordination system with the actual real people's human bodies and the actual thing. So maybe that's maybe next time try to use a digital analogies rather than the physical ones. I don't know if that makes sense.
Chuck in GB, you can use the theory of evolution and just watch the descent of man back to its origin. And that's your original start point, and you can trace every single bit as it comes up. And there isn't a fault at the end of it because we're all here.
remains, or is the big question of all this stuff, what's the connection to the real world? And so money is really some intermediary between the real economy, what we're doing here, and the information world. Keep track of it. And I think that's the weak point of all these tools. They are super tools, but as said, they don't get to the economy, and we want to change the economy. We don't want to change the super tools.
The made up numbers in the sky, yeah.
Yeah, something like that. Maybe you can also add a little part about reality and informational space or something like that.
Just on that.
Yeah, just also referring to what he said. So, two things in my opinion. They said you did an amazing presentation, and you did, which is great. The blockchain is super complicated, and it's not an easy thing to explain or to grasp. So thank you very much for that. I do think that there need to do a very strong distinguish between the Bitcoin or other cryptocurrency and the blockchain as a technology. They are not the same. And sometimes it's get very confusing because we are talking about the Bitcoin, whereas we are actually referring to the technology itself. The Bitcoin as a technology, a public ledger that can record and validate transaction of all kinds. We are talking about money because we have the Bitcoin, and here it's a local currency project, but you can do it for cargo weights, for music, for pictures, for everything that has a digital phenotype, and everything has a digital phenotype. It's just a better way to transact data, and not only for currency. And the Bitcoin itself, well, we don't know if actually this will be the currency that will prevail eventually. And nobody can tell now because there is no commercial usage of this technology, almost not in a grand scale at least. So the blockchain as a technology will be here to stay for a lot of usages. The currency or the monetary will be only one usage. And for that, I don't think nobody can tell what technology will be the technology that people will use. IBM is working currently with the banks on a private blockchain. If they will make the masses use their blockchain, maybe the Bitcoin blockchain will be obsolete in 5 to 10 years. And that's the last thing. It's a new technology. Satoshi or Satoshis, whoever they are, at 2009, only at 2012 people heard about the Bitcoin, and only in the past couple of years people are actually hearing about the blockchain. So it will take a couple of years until you're going to have commercial implementations.
Guys, thank you so much. Marloes, any?
Thanks for getting so involved and playing in the market and all your contributions and ideas.
Great. Round of applause for you guys.
Thank you.